Now this is a part of a video series that I'm going to do that's going to connect combinations, binomial expansions, and derivatives to Pascal's triangle. So let's just have at the binomial expansion. And what does that mean? Well, if I have something like x plus y and I square it, you probably know how to factor that out, but you probably know that that becomes x plus y times x plus y, right? And well, what does that become? That becomes x squared plus xy plus yx plus y squared, or x squared plus 2xy plus y squared. Okay? Now pay close attention here to the coefficients. That's the number that comes in front of the variables here. You have a 1, 2, and a 1 here. Okay? So now let's take a look at what would happen if I had x plus y cubed, right? If I cube that, well, that's that 3 times, right? X plus y times x plus y. And since I already found x squared, so that would be the same thing as x plus y squared times x plus y. And x plus y squared is just this thing up there. So that's equal to x squared plus 2xy plus y squared, right? That times x plus y. And what does that come out to be? Okay, so that will come out to be x cubed plus x squared y plus 2x squared y plus 2xy squared. I'm going to run out of room here. Plus xy squared plus y cubed. That's a lot. So if I simplify that, I'm going to get, well, look at these two. These two guys together make a 3, and these two guys together also make a 3. So I'm going to have x cubed plus 3x squared y plus 3xy squared plus y cubed. Now again, pay close attention to the coefficients. I have 1, 3, 3, 1 there. And I think the key here is to ask yourself, well, how many x cubed terms are there? How many x squared terms are there, right? How many x to the first power terms are there? And this is actually an x to the 0th power terms are there. And notice that it starts at x cubed and goes down by 1 each time. And y cubed starts on the right side and goes down 1 going this way. This is kind of an interesting pattern. I've seen this pattern before, and you've seen this pattern before in our combinations video. We have a 1, 2, 1, 1, 3, 3, 1. It's just Pascal's triangle. So this 3 right here, this guy, that 3, you could think of as being made by this 2 and this 1 together. They add together and get 3. And the other 3 is made by this 2 and this 1. Okay? So using Pascal's triangle, what should be the next step? It should be 1, and then these two together make a 4, and these two together make a 6, and these two together make a 4, and then the last one will be a 1. So that means that x plus y to the 4th power should be 1 x to the 4th, right? Then it should be plus 4 x to the 3rd y plus 6x squared y squared plus 4 x y to the 3rd plus y to the 4th power, right? And that should be it. And if that's not clear, you can think of it like this term right here and this guy right here always get increased by 1, right? This guy went from a 3 to a 4, and this guy went from a 3 to a 4. And the outside terms still have coefficients of 1. So that doesn't change. The only thing that changes is this new term in the middle. So there's quite a balance going on here. So with that, let's see if we can figure out what x plus y to the 5th should be, right? So it's going to have 6 terms. 1, 2, 3. Actually, let me make it a little bit nicer. 1, 2, 3, 4, 5, 6. And I'm going to save that for the next clip.